Hello and welcome to my channel. My name is Jess and I make Ren'Py minigame tutorials. And as usual, before we get into the video, I would like to thank all of my patrons who are supporting my channel. And since the last video, there's also 4 new patrons that joined, and those are Blake Grip, Marcus Merkel, Mythic Angel, and Christopher Jackson. And I hope that I have pronounced all of your names correctly. So thank you so much for joining and supporting my channel. So in this minigame tutorial, we're going to have a look at how to create a timing puzzle where the goal is to unlock a chest or a box by clicking with the mouse or a button on the keyboard at the right time. And to do that, we're going to need a bar that has a red zone together with a green zone and a sliding part that is going to be moving from side to side. And this spot needs to be in the green zone or the safe zone in order to unlock the box. So now let's have a look at the tutorial outline to learn more about the functionality of the minigame. So the bar for the slider is going to have a red zone and a green zone, where the green zone is going to be randomly placed inside of the bar. The slider will be moving from side to side with a speed that is determined based on how difficult that specific chest is to unlock. The player can only try a number of times to unlock the chest, and if they use up all of their attempts, they then lose. We will also implement some audio files that are going to be playing when the box unlocks or when the player fails and misses the safe zone. To follow along with the tutorial, you're going to need a new Ren'Py project in the size 1280 x 720 pixels using the latest version of the Ren'Py engine. You are also going to need the image assets used in this tutorial, which you can download from the description box below. It is also good if you have at least some basic Python programming knowledge to understand the coding a little bit better, but you might still find the tutorial interesting and useful either way. And the script from this video is available to download for patrons in the supporter tier, Ohio. So with that said, let's get started with the coding. So as usual, I've gone ahead and cleaned up the script file a bit so that I'm only left with the start label like this, and you want to do the same thing. And then you also want to make sure that you have added all of the images into the images folder of your project, like so. So the first thing we're going to add to the script is going to be a scene that will contain a background image together with a chest that the user can click on in order to start the timing puzzle that will allow them to unlock it. And to do that, we can use a screen because that will both allow us to add an image that will act as the background together with a button that the user can press on. And we can go ahead and do that just above the start label. So I'm going to create a few of the lines above here. And then we're going to say screen. And I'm going to call this screen scene 1. But you can of course call it whatever you want. And then we're going to add the background image. So we're going to say image and then background.png. And I always tend to make my images for the tutorials twice as large as what they should be displayed inside of the game. And that is just to make sure that they're not going to look too blurry when we are resizing the game to be full screen, for example. So for that, we're going to need to resize this to be half of its original size. And for that, I'm going to create a transform. So I'm going to do that just above the screen. And we're going to say transform and then half size. And then we're going to say zoom 0.5, like so. And now we're just going to apply the transform to this image. So we're going to say at half size. And then we're going to add the chest button that the user can click on. And for that, we're going to use an image button. So we're going to say image button. And then we'll use the auto keyword to allow Ren'Py to automatically switch between the idle and the hover state of the image. And then we're going to say chest closed %s.png, like so. So we're using the closed version of the chest image as the player hasn't yet unlocked it. And then we're going to add 2 actions to this image button. So we're going to say action. And then we're going to make a list of actions. So we're going to add 2 square brackets. And the first action is going to be to hide this screen so that we then can show another screen. So for that, we're going to say hide scene 1. And then we're going to show the minigame screen where the user is going to try to unlock the box. So we're going to say show. And this screen we are going to call chest puzzle, like so. And since the images for this image button are also twice as large as they should be displayed in the game, we're going to resize this to be half of its original size. But we are also going to add an animation to it that is going to make it zoom in and zoom out when the user is hovering over it. And that is just going to make it look a little bit more interesting. So for that, we are going to create a few of the lines underneath the other transform right here. And then we're going to say transform. And we're going to call this transform chest transform, like so. And the first property we're going to add is going to be the zoom property. So we're going to say zoom 0.5, and this is going to make sure that the image button is going to be half of its original size when it's first being shown. And then we're going to place the anchor point of the image button in the middle instead of in the corner. So we're going to say anchor, and then 0.5 and 0.5. And that will just make sure that the animation is going to happen from the center rather than from the corner. And then we can go ahead and place this image button on the screen. So we're going to use the align property for that. So we're going to say align, and this is going to be at 0.5 on the x-axis and then 0.7 on the y-axis. And then we're also going to add the subpixel property. So we're going to say subpixel, and we're going to set it to true. And this usually allows for a little bit of a smoother animation where the edges of the image that is being animated aren't going to look too pixelated. And now we'll go ahead and add the actual animation of the image button. And for that, we're going to use the on keyword and then specify the event where we want the animation to happen. So we're going to say on, and we're going to start with the hover event. So we're going to say hover. So as the user is hovering over the image button, we're going to have it zoom in just a little bit. So for that, we're going to say ease in to make the animation ease in, and then we're going to have it run for 1 second. So we're going to say 1.0, and then we're going to say zoom 0.51, and that will make it zoom in just a little bit. And then we'll add the other event, which is going to be the idle event. So we're going to say on idle. And here we want to make sure that the image button is going to zoom out again to its normal size. So we're going to say ease in 1.0 and then zoom 0.5, like so. And now we just need to apply this transform to the image button. So we're going to say at chest transform, like so. And now we just want to make sure that this screen is going to be the first one to show when we launch the game. So for that, we're going to call it from the start label. So we're going to say call screen scene 1, like so. So now we can go ahead and test to see if everything is looking correctly. So we're going to go ahead and save our changes and then launch the game to see what this looks like. So here I have the game open and running, and we can see that the screen seems to be showing as it should, with the background image right here and the chest in the middle. And if we hover over the chest, we can see that it switches image to the hover state, and it also zooms in just a little bit. And then we go away from the image button and it goes back to its normal state. So that is working correctly. So now let's go back to the code and continue. So now we're going to go ahead and create this chess puzzle screen, which is going to contain the actual minigame. So for that, we're going to create a few of the lines above this scene 1 screen. And then we're going to say screen chest puzzle. And inside of this screen, we're going to have 2 different versions of the chest image. One is going to be the locked or closed version, and the other is going to be the open version. And then depending on if the user was successful in opening the chest or not, we're going to show either one of these images. And to help us keep a track of whether or not the chest has been unlocked or not, we're going to create a new variable that is going to be set to either true or false. And to do that, we're going to go back into the start label, and we're going to create a $sign. And then we're going to call this variable chest unlocked. And as the initial value, it's going to be set to false, as it's going to be locked at the start of the game. In this screen, we are also going to show the user how many attempts they have left to unlock the chest. And for that, we're going to need another variable that will hold the number of attempts they have left. So for that, we're going to create a new line. And we're going to call this variable chest unlock tries. And this variable should be equal to the number of attempts that the user should have from the start. And in this case, we can set it to 2, but you can of course set it to another value if you want. So now that we've done that, we can go back up into the chess puzzle screen. And in here, we are first of all going to add the background image, which is going to be the same one as we used for the scene 1 screen. So for that, we're going to say image background.png, and then we'll resize it. So we'll say at half size. And now we're going to check if the chest unlocked variable is true or false, and then we're going to add the appropriate image accordingly. So for that, we're going to say if not chest unlocked. So this means that we're checking if the chest unlocked variable is not true. And in that case, we're going to add the locked version of the chest. So we're going to say image and then chest closed idle.png. And then we'll align it on the screen. So we're going to say align. And that is going to be at 0.5 and 0.7. And then we'll resize it. So we're going to say at half size. And then we'll do the opened version of the image as well. So we're going to add a new line and then go inwards once in the indentations. And then we'll say else. So if the chest unlocked variable is now instead true, then we're going to say image chest opened.png. And then we'll align this one as well. So we're going to say align 0.5 and 0.7. Now, as the user has unlocked the chest and this chest open image is going to be shown to them, we want it to be shown with an animation to make it look a little bit more interesting and impactful. And this animation is going to both fade in and zoom in on the image at the same time. So for that, we're going to create a new transform, and we can do that just above this screen. So we're going to say transform, and we can call this transform chest unlocked anim, for example. And then we're going to add the zoom property as the first property. So we're going to say zoom 0.5 to make sure that the image is going to be half of its original size when it's first being shown. And then as we are going to fade in the image, we're going to say alpha 0.0 to make it completely transparent at the start. And then we're going to add two parallel blocks that are going to make sure that the fade in and the zoom in animations are going to happen at the same time. So we're going to say parallel, and then we're going to say ease in 3.0 and then zoom 0.7. So now the image is going to zoom in for 3 seconds, and then we'll add another parallel block. So we're going to say parallel and ease in 2.0 and then alpha 1.0, like so. So now we are zooming in as well as fading in at the same time. So now let's go ahead and apply this transform to this image. So we're going to say at chest unlocked anim. And as I mentioned earlier, we also want to show to the user on the screen how many attempts that they have left to unlock the chest. And that we only want to show as long as the chest is unlocked, of course. So for that, we're going to create a new line above this image for the locked chest. And then we're going to add a frame. So we're going to say frame. And this frame is going to have a white background color. So we're going to say background. And then hash symbol and 6 F characters. And then we'll add a padding to it. So we're going to say padding. And this is going to be 5 and 5. And then we'll align it. So we're going to say align. And this will be at 0.5 and 0.3. And then we'll add the text that is going to show to the user the number of attempts that they have left. So for that, we're going to say text to add a text displayable. And then we'll say attempts left. And then to show to the user the number that is stored inside of the chest unlock tries variable, we're going to add 2 square brackets, like so. And then instead of him, we're going to say chest unlock tries, like so. So now this is going to be replaced with the number that it contains. And then we'll add a size for this text. So we're going to say size 18, and then color, which is going to be black. So we're going to add 6 zeros. And then we'll say text align 0.5 to make it center aligned. But you can of course experiment and change these properties to whatever you like. So now, just to make sure that everything is working correctly, we're going to save our changes and then launch the game. So now, let's go ahead and click on the chest to see what happens. And as we can see, that took us to the minigame screen where we have the chest in the middle right here, as well as the text up here that tells the user how many attempts they have left. So now that we know that that is working, we're going to go back into the code and continue. Now this screen is of course also going to need the red bar together with the save zone and the sliding part. And for the actual red bar, we can just add it as an image to this screen, but the other two are going to need to be sprites that we're going to create with the help of a SpriteManager. And this is going to make it much easier for us to change their positions on the screen as time goes on in the game. So for that, we're going to need to create a few more variables as well as a SpriteManager object. So we're going to go back down into the start label. And we are going to start with the SpriteManager object, which we are going to call slider_sm, and the SM stands for SpriteManager. And then we're going to say is equal to SpriteManager. And a SpriteManager can take two arguments. One is called update and the other one is called event. And these two arguments expects two functions. One function is going to run when the SpriteManager updates, and the other one runs when a user event happens in the game, such as when the user clicks with the mouse or presses on a key on the keyboard. And these two functions you create yourself, and then you supply them to the SpriteManager. And in this case, we only need one of these functions, and that is going to be the update function. So for that, we're going to say update is equal to, and we're going to call this function slider update. So now that we have created our SpriteManager object, we are also going to create a few variables. And the first variable we're going to create is going to be a list that's going to contain all of the sprites that we're going to be creating with this object. So for that, we're going to create a new line, and then create a $, and then say slider sprites, and then this is going to be equal to an empty list to start with. Then later on, we're also going to need to create some calculations that are going to help us to place the save zone and the slider inside of the red bar. And for that, we're going to need to know the size of the red bar to make sure that the placements are going to be correct. So for that, we're going to create a new variable that is going to contain the width and the height of the red bar. So we're going to create a new line, and then we're going to call this variable slider bar size, and this is going to be equal to a tuple. So we're going to add two round brackets, like so. And the size of the slider bar image, or the red bar, is as usual twice as large as what it should be displayed on the screen. So therefore we're going to have to divide the height and the width by 2. But because the division of the size is going to return float values, and these float values are going to cause a little bit of a problem for us later on, we are instead going to convert these into integers straight away. So for that, we're going to say int, to use the int function that is available in Python. And then instead of these two round brackets, we're going to add the width divided by 2. So for that, we're going to say 545 divided by 2, like so. And then we'll do the height as well. So we're going to add a comma after these two round brackets, like so. And then say int, and then 70 divided by 2. So now that we have done that, we can actually go ahead and add the slider bar, or the red bar, to the screen. And since this is just going to be a normal image rather than a sprite, we can just go ahead and add it with an image displayable. And for that, we're going to go back up into our chest puzzle screen. And then underneath this text, we can go ahead and add the bar. So we're going to create a new line, and then go inwards once in the indentations, like so. And then we're going to add another frame. So we're going to say frame. And the background for this frame is going to be none. So we're going to say background, none. And then we're going to say align, and this is going to be at 0.5 and 0.4. And then we'll give this frame a size, and this is going to be the size of the red bar. So we're going to say xy size, and then we can simply refer to the slider bar size variable. So we're going to say slider bar size, like so. And now we'll go ahead and add the image for the red bar. So we'll say image slider bar.png, and then we'll resize this to be half of its original size. So we'll say at half size. Now before we go ahead and launch the game to see that everything is working and looking correct, we're going to need to create this slider update function to make sure that we're not going to get any errors when we launch the game. So for that, we're going to create a few of the lines above the first line right here, and then we're going to create an init Python block. So we're going to say init Python, and then to create the function, we're going to say def slider update and then 2 round brackets. And this function takes one parameter, and that is st, which stands for shown typebase, and keeps a track of how long the SpriteManager object has been shown on the screen. And inside of this function, for now, we're just going to say pass, like so. And that just allows us to not have to add any specific code right away now. So now let's go ahead and save our changes and then launch the game to see what this looks like. So now let's go ahead and enter into the minigame puzzle again. And as we can see, we now got this red bar to show up right in the middle here. So we know that that is working correctly. So now let's go back into the code and continue. The next thing we're going to do is to create the safe zone as well as the slider sprites by using the SpriteManager object. And we're going to fill the slider sprites list with these 2 sprites in order to make it easier for us later on to access them and move them around on the screen. And for that, we are first of all going to need to create images for these sprites to use. And we're going to start with the slider image first. So we're going to create a new line. And then we're going to say slider image is equal to image. And then the path to this image is slider.png. But now, since this image is going to be twice as large as what it should be displayed in the game, we're going to need to transform it to be half of its original size. So for that, we're going to create a transform that is going to use this image as its child, and then we're going to use the transform as the image instead of the sprite instead. So for that, we're going to create a new line, and then we're going to say slider transform is equal to transform, and then child is equal to slider image, like so, and then zoom is equal to 0.5. So now we have created a transform displayable by using the transform function, and we're passing in the slider image as the child and setting its zoom to 0.5. Now we can go ahead and create the sprite that is going to use this transform as its child. So for that, we're going to create a new line and then say slider sprites and then dot append. So we're going to append an item to the slider sprites list. And in here, we're going to say slider sm dot create and then pass in slider transform as the child. So now we have created a new sprite using the SpriteManager object that we have called slider_sm and added it to the slider sprites list. Now we're also going to need to keep a track of the size of this slider image, just as we did up here with the bar. So for that, we're going to create a new line. And then we're going to say slider size is equal to, and then a tuple. And this is going to be int, and then 48 divided by 2. And then int, and then 66 divided by 2, like so. Now, just to make sure that the contents of our start label is going to be a little bit more readable and organized, we're going to go ahead and split the variables into sections using comments. So for that, we're going to go ahead and create 2 empty lines underneath the SpriteManager object, like so. And then we're going to call the first section slider variables, like so. And then above the chest variables right here, we're going to do the same thing. So we're going to add 2 empty lines and then a hash symbol and then say chest variables. And then we can also go ahead and add a new line underneath the chest variables to make a distinction between these variables and the call screen statement right here. Next, we're going to create the safe zone sprite. And for that, we can go ahead and create a few empty lines underneath the slider variables. And then we're going to create a new comment and call this safe zone variables. And then we'll create the image for the safe zone. So we're going to say safe zone image is equal to, and then image. And the path to this image is safezone.png. And then we'll go ahead and create the transform. So we're going to say safe zone transform is equal to transform. And then child is equal to safe zone image. And then zoom is equal to 0.5. And then we'll also need a variable for this one that is going to keep a track of its size. So we're going to say safe zone size is equal to, and then a tuple, and then int 149 divided by 2, and then int 70 divided by 2. And then we'll go ahead and create the safe zone sprite as well. So we're going to say slider sprites dot append, and then slider underscore sm dot create, and then safe zone transform, like so. Now, to make it easier for us to be able to pick the correct sprite from the slider sprites list later on, since we both have the slider and the safe zone inside of this list, we're going to go ahead and create an attribute to these sprites that we're going to call type, and this is then going to be equal to the name of the sprite in question. So then we can just compare the name of the sprite that we're looking for with the items inside of the slider sprites list to be able to pick the correct one. So for that, we are first of all going to create this attribute for the slider sprite. So we're going to go ahead and create a new line underneath here. And then we're going to say slider sprites, and then in 2 square brackets, we're going to say -1. And this just means that we are picking the last item inside of the slider sprites list, which will be the slider sprite, since that is the last one we created right here. And then we're going to say dot type is equal to, and then slider, like so. So now the last item in the slider sprites list, which is the slider sprite, is going to have a type attribute that is equal to slider. And then we'll do the same thing for the other one. So for that, we can just go ahead and copy paste this right underneath here. And then we'll just rename this to safe zone, like so. Now, before we continue and add these sprites to the chess puzzle screen, we're actually just going to switch the order of the safe zone and the slider sprites, just to make sure that the slider is going to appear above the safe zone rather than the other way around. So for that, we can just go ahead and cut out this section and then paste it underneath the safe zone. And then I'll just go ahead and clean up these empty lines, like so. And now we can go ahead and add the sprites to the screen. So we're going to scroll back up here to the chess puzzle screen. And then to add them, we're going to add the SpriteManager object. So we're going to create a new line underneath this slider bar. And then say add slider underscore sm, like so. So now let's go ahead and save our changes and then launch the game to see what this looks like. So now let's go ahead and click on the chest to enter into the chess puzzle screen. And here we can now see that we've added our 2 sprites, which is the safe zone right here and the slider right here. And they automatically align perfectly inside of this bar since they have the correct size and are all contained in the same frame. So now that we know that that is working correctly, we're going to go back to the code and continue. The next thing we're going to do is to make sure that the slider sprite is going to be sliding from side to side inside of the red bar. And for that, we're going to be using the slider update function that we have created for the SpriteManager object. But before we go ahead and do that, we're actually going to need 3 new variables that we're going to be using inside of this function. And these we're going to be calling slider speed, chest difficulty, and stop slider. So the first one, slider speed, is going to determine the speed of the slider together with the chest difficulty one, because the more difficult the chest is to unlock, the faster the slider is going to move. And the stop slider variable is just going to help us to determine whether or not the slider should keep moving or stop, such as when the user clicks with the mouse at the correct time where the slider is overlapping the safe zone. So let's go ahead and create these variables now. So the first 2 are going to be the slider variables. So we're going to create it in the slider section. So we're going to say slider speed, and this is going to be equal to 2, but you can of course experiment to see which speed you like the best. And then we'll create the other one, which is slider stop, and this is going to be a Boolean variable, so it's going to be either true or false, and as a default it's going to be set to false. And then we have the chest difficulty variable, which we are going to create in the chest variable section. So we're going to say chest difficulty is equal to, and as a default value, I'm going to set this to 1 for the easiest difficulty. But then later on, when the user is going to click on a chest in a specific scene, we can always change the difficulty to a different value. So now that we've done that, we're going to go back up into the init Python block. right here. And in the slider update function, we're going to add some code in order to move the slider. Now inside of this function, at some point, we're going to be changing the value for the slider speed variable. And to do that, we are first of all going to need to make it into a global to make sure that we are not going to get any errors thrown in the game. So for that, we're going to say global slider speed, like so. So now we're going to go ahead and move the slider sprite inside of the red bar. But for that, we are first of all going to need to pick it from the slider sprites list. And to do that, we're going to compare its name to the names of the items inside of the list. And that will then ensure that we're going to get the correct item. So for that, we are first of all going to need to loop through the list to get the correct item. So we're going to say for sprite in slider sprites, like so. And then we're going to compare the name of the sprite that we're looking for. So we're going to say if sprite.type is equal to, and we're of course looking for the slider, so we're going to say slider, like so. So now if this if statement is true, then that means that we have identified the correct sprite that we need to move. Now to move the sprite, we're going to need to create another attribute, like this type attribute, but we're going to call it direction instead. And this one is going to help us to determine which direction that the sprite needs to move in. So if it's all the way to the right, we need to move it to the left. And if it's all the way to the left, we need to move it to the right. So we're going to scroll back down to the start label. And then here in the slider variables, we're going to go ahead and duplicate this line where we have added the type attribute. So I'm going to press Ctrl-Shift-D on my keyboard to duplicate that. And then we're just going to rename type to direction. And the default direction that we're going to move the slider in is going to be to the right. So we're going to say right. And that is because at the start of the game, the slider is on the left side of the bar. And then we'll go ahead and go back up into our function. And in here, we're going to go ahead and create another if statement that is going to check if the slider has not yet reached the right side of the bar and if its direction attribute is equal to right. Because if that is true, then that means that we want to keep moving the slider to the right. So for that, we're going to say if, and then round, and then instead of these two round brackets, we're going to say sprite.x, and then we're going to say is less than slider bar size, and then we're going to pick the width of the slider bar. So we're going to add a 0 inside of these two square brackets, and then say minus slider size, and then pick the width of the slider. So what are we actually doing with this if statement? Well, we're checking if the sprite's x position is less than the width of the slider bar minus its own width. And if that is true, then that means that the sprite has not yet reached the very right side of the bar. And in such a case, we're going to keep moving it to the right until it does. But then we also want to make sure that we are checking if the sprite's direction attribute is at the right. So we're going to say and sprite direction is equal to right, like so. Now to move the sprite to the right, we're going to use the default x attribute that is available for a sprite object. So we're going to say sprite.x. And now since we want to move the sprite to the right, we're going to say plus equals to make sure that whatever value we are placing after the equal sign is going to be added to the x attribute instead of replacing it. And then we're going to say slider speed times chest difficulty, like so. So the slider speed times the chest difficulty is going to determine how much the sprite is going to move to the right. Now this is going to cause the sprite to move at an equal speed until it has reached the right side of the bar. But to make the game a little bit harder, we're actually going to speed it up by just a little bit for every move that it's doing. And for that, we're simply going to add a small value to the slider speed variable every time the slider moves. So for that, we're going to create a new line, and then we're going to say slider speed, and then plus equals, and in this case, I'm going to add 0.04 to this variable. And that is then going to make the slider move just a little bit faster every time it moves. And this is all that we need to do in order to move the sprite to the right. But now if this if statement instead evaluates to false, then that would mean that the sprite has now reached the very right side of the bar, and we now want to move the sprite to the left instead. And to do that, we're going to create another if statement that is going to check if the sprite has not yet reached the very left side of the bar, and if the sprite's direction attribute is still set to right. because if that is true, then we're going to make sure that the direction attribute is instead set to the left and that we reset the slider speed variable back to its initial value. So for that, we're going to create a new line and then go inwards once in the indentations and then say elif round sprite.x is more or equal to slider bar size and then 0 inside of these two square brackets and then minus slider size and then 0, like so. And then we'll also say and sprite direction is equal to right, like so. And then we'll say sprite dot direction is equal to left, because now we're switching the direction to the left instead. And then we're going to say slider speed is equal to 2, which was the initial value. So now that we have switched the sprite's direction to left instead, we're going to go ahead and move it to the left. And for that, we're going to create another if statement again. So we're going to create a new line and then go inwards once in the indentations. And then we're going to say elif round sprite.x is more than 0 and sprite.direction is equal to left. And this would mean that the sprite has been set to move to the left and it has not yet reached the left side of the bar. So now we're going to say sprite.x minus equals to slider speed times chest difficulty, like so. So now we are subtracting the value after the equal sign from the sprite's x attribute. And this will move the sprite to the left instead of to the right. And then we'll do the same thing to the slider speed variable as we did when we moved the sprite to the right. So we're going to say slider speed plus equals 0.04. And then the very last thing we're going to do in terms of moving the sprite is to make sure that we are switching the sprite's direction back to right once it has reached the very left side of the bar. So for that, we're going to say elif round sprite.x is equal to 0. So this would mean that the sprite is now flush against the left side of the bar. And then we're going to say and sprite.direction is equal to left. So now we want to move it back to the right. So we're going to say sprite.direction is equal to right. And then we're going to reset the slider speed again. So we're going to say slider speed is equal to 2. Now the code that we've written so far for this function is only going to be useful to us as long as the function is going to continuously run to make sure that the sprite is going to keep on moving to the left or to the right. And for that, a SpriteManager object's update function actually allows us to use the return statement and then supply the number of seconds that we want the function to wait for until it's going to automatically run again. And so we're going to use that and set it to 0 to make sure that the function is going to run every second. But we only want the function to keep on running as long as the stop slider variable is set to false, because if it's set to true, then we want to stop the slider. And that would be in cases such as when the user clicks with the mouse or presses a key on the keyboard at the right time where the slider is overlapping the safe zone. And for that, we're going to create an if statement that is going to check if the stop slider variable is set to false, and if it is, then we'll use the return statement together with the value of 0. But if it's set to true instead, then we're going to use the return statement together with the value of none. And that will then just stop the function from continuously running. So we're going to go ahead and create a new line, and then go inwards 3 times in the indentations, like so. And then we're going to say if not slider stop, and then instead of here we're going to say return 0. And then underneath we're going to create a new line and then say else, and then return none, like so. So before we go ahead and launch the game to see how everything works like, we're just going to do a few corrections in the code. So right here on this line where we are assigning the value right to the direction attribute, we're of course only going to use one equal sign, like so, because we are assigning a value rather than comparing two to each other. And then in the start label, we're going to move this slider sprites variable to be above the safe zone variables. So I'm going to cut this out and paste it up here, like so. And that is just so that we don't get any errors when we launch the game, because we're trying to access the variable right here too early on before it has been created. So now that we've done that, we can go ahead and save our changes and then launch the game to see what this looks like. So now let's go ahead and click on the chest again to enter into the minigame. And here we can now see that the slider is moving from side to side inside of the bar, and we can also see that it speeds up just a little bit before it reaches either end. So we know that is working correctly. So now let's go back to the code and continue. Now we need to allow the user to be able to click with the mouse or press on a key on the keyboard in order to try to get the slider in the safe zone. And for that, we're going to go back up into our chest puzzle screen right here. And here we're going to add a key displayable that is going to detect a mouse click or a button press on the keyboard, and then run an action that is going to check if the slider is overlapping the safe zone. And if it is, then the user wins the game. So we're going to go ahead and do that just above the background image right here. So we're going to say key and then 2 square brackets so that we can add 2 keys. And the first one is going to be K and then underscore space, and this is going to be in all caps, and then comma, and then mouse down underscore 1. And these are the key map names for the space key and the left mouse button. And I will leave a link into the description box below where you can read more about the different names for the different keys. And then we'll go ahead and add an action. So we're going to say action. And the action is actually going to be dependent on whether or not the chest unlocked variable has been set to true or false, because there's 2 scenarios where we're going to have something happen when the user clicks with the mouse or presses on a key on the keyboard. And the first scenario is when the user is trying to unlock the chest by aligning the slider with the safe zone. And the other scenario is when the user has already unlocked the chest and want to progress to the next thing after the minigame. And in such a case, we're just going to hide the chest puzzle screen and then transfer the user back to scene 1. But you can of course transfer them to whatever screen or even label that you want. So for that, we're going to create an if action. So we're going to say if, and then we're going to add the condition that we're going to look for inside of here. So we're going to say chest unlocked, and then we're going to add a comma and then say true is equal to. So if the chest unlocked variable is equal to true, then whatever action we're going to add here is going to run. And as I mentioned before, we're going to do 2 things here. One is to hide this minigame screen, and the other is to show scene 1. So for that, we're going to add a list. So we're going to add 2 square brackets and then say hide chest puzzle, and we're going to hide the screen together with a transition. So we're going to add a comma just after the last quotation mark, like so, and then say transition. And this is going to be a custom fade that is going to fade in, hold, and then fade out for 1 second each. So for that, we're going to say fade, and then 1, comma, and then 1. And then after these 2 round brackets, we're going to add another comma, and then say show, and then scene 1, like so. And then we'll add the action that is going to run if the user is instead trying to unlock the box. So for that, we're going to add a comma after the square bracket, like so, and then say function. And the function is going to be called check slider safe zone. So now, if the chest is unlocked, then we're going to run these 2 actions that is going to hide chest puzzle and then show scene 1. But if it hasn't been unlocked, then we're going to run this function instead. And now we're going to go ahead and create this function. So we're going to scroll back up into the init Python block. And then underneath the other function, we're going to create a few empty lines. And then go inwards twice in the indentations, like so. And then we're going to say def check slider safe zone. And inside of this function, we're going to need to change the values for some of the variables that we have created earlier on. So for that, we're going to need to make them into globals first. So we're going to say global, and the first one is going to be chest unlocked. And then we'll do another one, which is going to be chest unlock tries, like so. And then the last one is going to be stop slider. So we're going to say stop slider, like so. And now we're going to check if the slider sprite is overlapping the safe zone sprite. And to do that, we're going to create 2 for loops. One is going to help us to grab the slider, and the other one is going to help us to grab the safe zone. and then we're just going to check if these two are overlapping each other. So for that, we're going to create two empty lines, and then we're going to say for slider in slider sprites, and then we're going to check if the current sprite in this for loop has the type attribute set to slider. So we're going to say if slider dot type is equal to slider, because if that is true, then we have identified the slider sprite. And then we'll create the second for loop. So we're going to say for safe zone in slider sprites, and then we'll say if safe zone dot type is equal to, and then safe zone, like so. And now we'll compare if these two sprites are overlapping each other. So for that, we're going to say if safe zone dot x is less than slider dot x, and then again is less than safe zone dot x plus slider safe zone size, and then we'll grab the width of the safe zone. So with this if statement, we're checking if the slider's x position is more than the safe zone's x position, and we're also checking if it's less than the safe zone's x position plus its width, because if that is true, then that means that these two must be overlapping. So then that means that the user has then successfully opened the chest. So in that case, we're going to say chest unlocked is equal to true, and then we're going to stop the slider. So we're going to say stop slider is equal to true, and now we're also going to play an audio file of the chest opening. So for that, we're going to say Ren'Py dot play. So we're using the play function available in Ren'Py, and then we're going to add a path to the audio file, which is going to be audio slash open door.og, like so. And then we have to specify the channel that we want to play this audio on. So we're going to say sound, like so. So now all of this code is going to run whenever the user gets the timing correct and therefore unlocks the chest. But now we also need something to happen when the user misses the safe zone and therefore gets the timing incorrect. And in such a case, we're going to play an error sound as well as subtract 1 from their attempts. So for that, we're going to create a new line and then go inwards once in the indentations, like so. And then say elif chest unlock tries is more than 0, because we only want to subtract 1 from the chest unlock tries variable as long as they still have attempts left. And then instead of here, we're going to say Ren'Py dot play, and this is going to be the error sound. So we're going to say audio slash error dot og, and then comma and sound. And now we'll subtract 1 from the attempts. So we're going to say chest unlock tries minus equals 1. Now there's also one more scenario that we have to add, and that is if the user has used up all of their attempts, and therefore the chest unlock tries variable is now equal to 0. And in such a case, we're just going to show the user the game over screen. So for that, we're going to create a new line, and then say elif chest unlock tries is equal to 0, and then Ren'Py dot show screen, and the game over screen we're going to call game over, like so. And now we also want to stop the slider from moving, so we're going to say stop slider is equal to true. And I also just now realized that I have misspelled the safe zone in this if statement right here. So instead of saying safe zone type is equal to safe underscore zone, we're going to say safe dash zone, like so. And then down here in this if statement, I have incorrectly named the safe zone size variable as slider safe zone size. So we're just going to remove the slider part of that, like so. Now one last thing we need to do is down in the chest puzzle screen. So we're going to scroll back down to here. And here in the key displayable, where we have added the action, where we are testing if the chest unlocked variable is equal to true or false, I have added the true parameter right here together with the two actions, but then I have forgotten to add the false parameter for this function call right here. So we're just going to go ahead and add that now. So we're going to say false is equal to, and then we have the function call, like so. So now we can go ahead and save our changes and then launch the game to see what this looks like. So now, as usual, we're going to go ahead and click on this chest to enter into the minigame. And now we're going to try to get the slider in the correct position, which is inside of this green zone. So I pressed on the space key in this case, and we can see that the chest is now unlocked. So now we know that unlocking the chest works correctly. So now we just need to test what happens if we get it incorrect. So for that, I'm going to go back to the main menu and restart the game. So now I'm going to go ahead and test that again. So this time I'm going to click with the mouse in the red zone to see what happens. And as we can see here, the attempts went down to 1 because we had 2 to start with. Let's try it again. And this time it went down to 0. And now we just need to make sure that the game over screen is going to be triggered in a case like this. So we're going to go back to the code and do that now. So now we're going to go ahead and create the game over screen. And we can do that just above this chess puzzle screen. So I'm going to go ahead and create a few of the lines above here. And then say screen, game, over. And this is going to be a modal screen. So we're going to say modal, true. And then we're also going to add a key displayable that is going to allow the user to hide the screen. So we're going to say key, and then K, space. But you can of course add more keys if you want to. And then action. And the action is actually going to be 2 actions. One of them is simply going to hide the screen, and the other one is going to reset the minigame. So when the user encounters another chest, they can play the game again. So for that, we're going to add 2 square brackets, like so. And then say function. And this function we're going to call reset chest puzzle, like so. And then we're going to add a comma and then say hide game over, like so. And then we'll go ahead and add the content for the screen. And first of all, we're going to add a frame that is going to have a black transparent color that is going to separate the chess puzzle screen from this game over screen. So we're going to say frame and then background. And to make a transparent black color, we're going to add a hash symbol and then 6 zeros. And then 80, and that is going to make it 50% transparent. And then we're going to stretch this frame to cover the entire screen. So we're going to say xfill, true, and yfill, true. And then we're going to add another frame that is going to contain the text game over. So we're going to say frame. And this one is going to have a transparent white color. So for that, we're going to say background. And then we're going to add a hash symbol and 6 F characters. And then E6, which will make it 90% transparent. And then we're going to stretch this frame as well, but only on the x-axis. So we're going to say xfill, true. And then we'll also add a little bit of a padding. So we're going to say padding. And that is going to be 15 and 0. And then we'll align it. So we're going to say align. And that is going to be at the center of the screen. So we're going to say 0.5 and 0.5. And then the last thing is going to be the text. So we're going to say text, game, over. And then the color, which is going to be black. So we're going to say color. So hash symbol and then 6 zeros. And then we'll add a size. So we're going to say size 34. And then we're going to align the text in the center of this frame. So we're going to say x align 0.5, like so. And then one of the very last things we need to do is to create this reset chess puzzle screen. And that we're going to do back in the init Python block right here. So we can create a few of the lines underneath the last function right here. And then go inwards until we are in the same indentation as the other function right here. And then we'll say def reset chest puzzle. And then in here, we're going to need to reset some of the variables. So for that, we first of all need to make them into globals. So we're going to say global. And the first one is going to be chest unlocked. And then we'll do another one, which is the chest unlock tries. Like so. And then we need stop slider as well. And then slider speed. Like so. So now we'll go ahead and reset these variables back to their initial values. So first we're going to say chest unlocked is equal to false, and then chest unlock tries is equal to 2, and then stop slider is equal to false, and slider speed is equal to 2. And now this function we are also going to be using in order to randomly place a safe zone inside of the red bar, because then we can just call this function every time we want to show the chess puzzle screen, and the safe zone is always going to be in a random position. And then we'll also of course reset the slider sprite back to its initial position as well. So for that we're going to create a few of the lines, and then say for sprite in slider sprites, and then we're going to grab the slider sprite first and reset its position. So we're going to say if sprite.type is equal to, and then slider, and then to reset it we're going to say sprite.x is equal to 0, and then we grab the safe zone sprite. So we're going to say elif sprite.type is equal to safe zone, and to randomize its position on the x-axis we are first of all going to create a new variable that is going to store this random value. So we're going to say random x is equal to, and then we'll use the randint function available in Ren'Py. So we're going to say Ren'Py dot random dot randint, and then instead of these two round brackets we're going to supply two values, and then the randint function is going to use these two values to generate a random value between. And this is going to start at 0, and then it's going to end in the width of the red bar minus the safe zone's width. So for that we're going to say slider bar size 0, like so, and then minus safe zone size, and then 0, like so. And then we're just going to supply this value to the safe zone's x attribute. So we're going to say sprite.x is equal to random x, like so. And now in order for these changes to take place in the game, we're going to need to redraw the SpriteManager object and then also restart the interaction. So for that we're going to create a few of the lines, and then go inwards 2 times in the indentations, like so, and then say slider underscore sm dot redraw, and then we'll pass in a 0 to the redraw function, like so, and then say Ren'Py dot restart interaction, like so. Now before we go ahead and continue, we actually just need to make a quick correction up here in the check slider safe zone function, and that has to do with this last elif statement right here. So this elif statement is actually going to need to be just an if statement, so we're going to remove the el in front of that, like so. And the reason for that is, in Python code and many other languages, when you have several else if statements following each other, if one of the above else if statements evaluates to true and its code inside runs, then that means that any other else if statements that follows won't be evaluated and run its code at all. In our case, we actually need this if statement to be evaluated and potentially run the code inside, no matter if this if statement or this if statement above evaluates to true. And since we have changed it to an if statement, it's going to run either way. Now we're just going to do one more fix in our script before we can go ahead and launch the game. And that has to do with this stop slider variable, because down in the start label I have namely called it slider stop instead of stop slider. So we're just going to rename it to stop slider instead, like so. And this variable name is what I'm referring to everywhere else in the script as well, except for up in the update function. So we're going to scroll back up and change the name to stop slider as well. So stop slider, like so. So now we can go ahead and save our changes and then launch the game to see what this looks like. So now let's go ahead and test the minigame again. And I'm going to start with using up all of my attempts by getting the timing incorrect, and then we'll see what happens. And as we could tell there, every time I clicked with the mouse and the slider was in the incorrect position, an error sound played, and then when all of the attempts had been used up, the game over screen then showed. So now let's go ahead and try this again by pressing on the space key in order to hide the game over screen and also reset the minigame. And this time we can see that the safe zone has now switched places to a random location inside of the bar. So now let's go ahead and try to unlock the chest by getting the correct timing. And as we can see, that also worked as intended, as the chest is now open, and we also got the open door audio file to play. So now we're going to go back into the script and do some finishing touches, and then I'm also going to give you some tips on how you can customize the script in various places that you might find interesting and useful. So let's go back to the code and do that now. So the next thing we're going to do is to make sure that the chess puzzle screen is always going to reset the minigame every time it's being shown, and that will make sure that the chest is always going to be locked when the minigame starts. So for that, we're going to go back down to the chess puzzle screen, right here, and in here we're going to add an on displayable that is going to run an action every time the screen shows. So for that, we're going to say on, and then instead of 2 quotation marks, we're going to say show, and then action. And this action is going to be a function call to the reset chess puzzle function. So we're going to say function, and then reset chest puzzle, like so. So now we have actually completed the coding for the minigame, as we have added all of the things that it needs in order to work. So now I'm just going to give you some tips on things that you can add or change inside of the script that I know that some of you are going to be wondering about. So one of the questions that you might have is, how can I implement several chests in my game with different difficulties? And to do that, you will need to create several of these types of screens that we have created down here and called scene 1. So basically, you would just create different scenes that are screens containing whatever you want, together with the image button that represents a chest that the user should be able to unlock. And then to switch the difficulty for that specific chest in this scene, you would add a third action to the image button that will set the chest difficulty variable to a new value. So as an example, you would write a comma after the last action, like so, and then say set variable. And the variable that you want to set is chest difficulty. And then you add a comma after the 2 quotation marks, like so. And then the value that you want to set the difficulty to. In this case, I'm going to set it to 3. And depending on how high you set the value, the slider is of course going to move a lot faster. So you just want to be mindful of that when you choose a value. Another question that I think some of you are going to have is, how can I make sure that a chest that has already been unlocked once in a scene does not have to be unlocked again when the user comes back to it? And that is actually going to be an exclusive mini tutorial for my patrons in the tier voting Ohio. So if that sounds interesting to you, make sure that you go over to my Patreon page and check that out. But thank you so much for watching, and I hope that you found this video interesting and educational. And if you have, please leave a comment down below to let me know, and also press the like button as it's very helpful for the channel. And as always, I'll see you in the next video.